everyone. Thanks for having me. I'll just introduce myself. My name is Tiffany Clouston, and I'm the manager or clinical specialist of molecular diagnostics and cytogenetics at the St. John Regional Hospital. Today, I'd just like to talk to you about how we've decided to make the move toward optical genome mapping at our site. So we were recently faced with a set of new beginnings. We just had a strange convergence of circumstances that brought us to making the decision to move toward OGM. And I'll go through those in the next few slides. So first of all, our cytogenetic caseload continues to increase as time goes on. There's data here that's plotted from 2016 until 2024. So you can see that there's a pretty steady increase in demand for cytogenetics at our institution. And we don't expect that to slow down anytime soon, as I'm sure most of you can relate to. The demand continues to increase. Our current workflow looks something like this. So our primary sample types that we have are bone marrow and peripheral blood. We do get some cord bloods and tissues that we send out for testing at the moment. So the samples go through this pre-analytical process of being cultured and harvested, and they're brought down to a blood cell pellet in a fixative. From that point forward, they move into our analytical stage here, where a technologist takes a few drops of that cell pellet, puts it on a slide, dries it, stains it, and then it goes on for karyotyping analysis, or the cell pellet might go on to fish analysis, depending on what the workflow dictates. So some elements that we took into consideration were our human resource challenges. Like all of you, I'm sure, are experiencing similar issues. We're having a difficult time recruiting staff. We've also experienced some sample-related workflow inefficiencies and some challenges with capital equipment and space, and I'll touch on each of these things in the coming slides. So I'll get started with human resources. This is not going to be news to anybody. I think every healthcare institution worldwide right now probably is facing some sort of challenge with retaining and recruiting staff, and we are no exception to that. So in Canada, all of our medical laboratory technologists require, at minimum, a general MLT certification with the CSMLS. We do prefer that they have a genetics certification to work in molecular. However, in the cytogenetics lab, it is mandated that anybody who is performing cytogenetic analysis has a genetics certification. We are located in New Brunswick, so specifically in New Brunswick, this has been a challenge because the only two training institutes in Canada that offer that certification are in Toronto and British Columbia. So those are a fair distance away from us, and it's challenging to recruit graduates from those programs to a small province like New Brunswick when they're coming from a larger city that's pretty far away. So ideally, the medical laboratory technologist would perform the bench work, the preliminary data analysis, and the draft report generation that goes off for final sign out by the geneticist. Again, to get those ideal cytogenetics technologists has been a really big challenge. We've looked at sending some of our general MLTs for training to obtain that genetics certification, but as of yet, there's been little interest in that. It adds training time onto them. They'd have to move away to another site in another province to take the training program. And all of that would be done to come back to New Brunswick and work at the same pay grade as our current general medical laboratory technologists are paid. That has to do with some union issues, which I'll touch on in a little bit as well. Another challenge that we have is that we have a really small team. So we have some restrictions with cross-training. So a lot of our demand right now is more on the molecular side of the lab versus the cytogenetic side of the lab. So maintaining proficiency in cytogenetics would be a challenge, even if we had a large number of cytogenetics certified technologists, because there just isn't enough of a demand in the cytogenetic section to keep multiple people proficient over time. With all of that said, it can be really difficult to find backup if any of our staff members need to take vacation or have to leave on emergency leave or any other kind of leave that they might require. So we're at a bit of a risk with our current setup with traditional cytogenetics methods because of all of our staffing constraints. In New Brunswick, we're also regulated by a union, so all of our staff members are union members. It's really great for the staff members. It gives them flexibility and choice. So they're all in the same union. They can go work in chemistry or hematology or pathology. They do have flexibility in job choice. However, while that's great for the staff, it's caused a lot of turnover for us. So we're constantly training new technologists, which can be really difficult when the techniques are so specialized. We also have a lot of staff who will come in and cover temporary leaves and then go on to another temporary leave or casual positions. So training has been challenging. In New Brunswick, our full-time equivalencies or our positions are dictated by our workload. So in a province the size of New Brunswick, we have a relatively small workload. So we have fewer FTEs employed within our lab compared to larger provinces like Ontario would. So once again, just because we have a smaller number of FTE positions in the lab, we have less flexibility with things like leaves and so forth. So just for example, we have about 6 technologists total in our lab. So if one person goes on vacation, that brings our staffing down about 16, 17%. So it can be a challenge to backfill them. Another issue that we've encountered a few times is with our turnaround times. And that's because right now we have a very fragmented testing process. So one staff member will perform the culture and harvest, another will do the staining, banding, and scanning of our slides. Right now, our most senior cytogenetics technologist just retired, so we've enlisted the help of a couple of contractors. So we're sending out our samples for preliminary analysis by one contractor. They then get sent on to a second contractor for secondary analysis. That data gets entered into our LIMS system and then goes off to a geneticist for final sign out and report release. So at any point in that process, if any of those people go on vacation or take a leave, we experience an increase in our turnaround time. So that is, again, at a detriment to our patients as they sit and wait for results. So the next challenge that we have faced are some sample-related workflow inefficiencies. We deal with a lot of irretrievable samples. Like I mentioned, most of our samples are bone marrow. We do get some peripheral blood samples and cord bloods and cord tissues and so forth. But because our sample viability is so short, we have to process them as if they are all going to go for testing, even though that might not be the case. So right now, our hematopathologists do some triaging of the samples and they decide whether or not testing is required. But we may not always hear back from them within a really timely manner. So we process the samples to ensure the sample viability within a certain time frame. So that leads to some wastage of technologist time and consumable materials and so forth. So our next challenge has been with capital equipment and space. If there are any managers who are listening, I'm sure you can relate to the challenges with capital equipment. This is a sort of a snapshot of something like what we currently have in our lab. So you can see there's considerable amount of lab equipment and lab instrumentation. There is a microarray set up on the left-hand side. I will point out that we don't actually perform microarray at our institution. We're currently sending those out. But we do nucleic acid extraction. We have qPCR instruments. We do the culture and harvest of bone marrows and peripheral bloods. We're G-banding. We're capturing all of those karyotyped images to send out. And then we also have a fish lab set up in a different area of the lab, which actually takes up 2 small rooms in a different lab. So we're very spread out. It takes up a large footprint. It can be very expensive to maintain all of this equipment with their service contracts and the consumables that go along with them and so forth. So that's been a challenge. In addition to that, securing any capital equipment can be a very difficult process. So at our institution, we're competing with all of the other departments within the hospital for capital equipment funding. So in order to justify any purchase of capital equipment, we have to write a really solid business case. We have to fight to prioritize the items that we need. And it can be a really rigorous process. And even if you have a rock solid business case, if the funds aren't available, we may be denied funding for that capital equipment. So that can be a hindrance in us updating our supplies, which has proven a difficulty in the past. So all of those things together have led us to decide to move forward with optical genome mapping. It's solved a lot of the issues that we have experienced. First, I'll show you this snapshot. So the image on the left is the image that I showed you previously, which is very similar to our current setup, where we have a couple of rooms with fish equipment. We have a cytogenetics lab full of culturing and harvesting and G-banding and image capture supplies. And then we have a whole other section, or we actually send out for microarray at the moment. So there's a lot of footprint, a lot of money that's going into things that we are now moving towards streamlining into the single Bionano workflow. So instead of all of that equipment on the left-hand side, now we can do a simple DNA extraction. We can label our samples, load them onto the OGM platform, which has a relatively small footprint, and then analyze those samples all in one go. So we get that whole genome structural variant analysis at high resolution from optical genome mapping, which has cut down on a lot of our repetitive testing that we've experienced before, where we're sending things for fish and we're sending things for microarray, and then we're sending it for karyotyping. Now we can kind of capture all of that information with just OGM. Okay, so in summary, OGM has given us a lot of advantages that we were looking for, and it's ticked a lot of the boxes that we had previously identified as issues. So the first one is that it's really streamlined our molecular technique. So now we don't need that special genetics technologist certification. We can train our general medical laboratory technologists to work on this bench. So with that, we can rotate people through the OGM bench more regularly, which means that they can maintain their proficiency. And it also gives us additional backup for any vacations or leaves that come up. We will be able to save some money on our operational budget by not having to process the samples right away. So we can actually aliquot and freeze our bone marrows and our peripheral bloods until we decide whether or not they need to be tested. We no longer have to do any of that initial processing ahead of time to maintain the viability of the sample. That has saved technologist time, as well as reagents and disposables in the process. We can also do whole genome testing versus panel testing, like I mentioned. So we're not sending it for multiple different levels of testing. It's all done in one straightforward test. And it's improved our turnaround time. So we have a really efficient work process now where we go from sample extraction to sample labeling and running within the span of 3-4 days, whereas before we had that really fragmented work process. A lot of the analysis also happens on the server, so we can take advantage of some weekend and overnight time to let the server work and process some of the analysis. It's very space efficient, so just thinking back to that image where we used to have multiple pieces of instrumentation in multiple rooms, now we have things all in one really streamlined workflow. And specifically with Bionano, we've experienced excellent customer support. So we have regular weekly meetings, or sometimes more frequent meetings, with every level of customer support representative that they have. We've had help with sample extraction all the way through to complex data analysis with the VIA software that they have. So that at every single step of the way, they've been able to match us up with somebody who can help us work through the issues that we're having at that time. We are also using their clinical reporting software, VIA, which has been very helpful. And again, they've helped train us on the analysis with that software, and they've been there to help us troubleshoot and kind of customize it for the applications that we would like to use. On the flip side, there are a couple of little disadvantages. It hasn't been absolutely perfect. So in terms of turnaround time, I did mention in the advantages that we are experiencing a decreased turnaround time. However, it's not quite as decreased as we thought it would be. So we were hoping that we could go from sample extraction to labeling and running within 2 days. And we have come across a couple of samples where we've had to let them homogenize over the span of 48 to 72 hours before we can label them. And the data collection process can also take some time. So the chip can sit on the instrument for up to 65 hours, collecting the data on the chip. And within that time, you can't load another chip. So that has taken some time. The data analysis is complex and requires subject matter expertise. So that really highlights the role of a data analyst. But like with our other human resource challenges, there's a limited availability of data analysts, and there's a lack of training programs in OGM simply because it's so new. Although we have heard from at least one master's student recently that they've been starting to learn about OGM during their master's programs. So that is looking like it might improve in the future. And then just some final disadvantages with the clinical reporting software VIA. The setup still relies on Bionano access, and it's not completely seamless. And there's still some inability to generate a complete clinical report at this moment in time. So there may be some improvements coming in the future. Right now, the report generation is restricted to known targets or panels, and it's generated as a Word document and saved outside of the platform. So that makes it easy to edit, and things could get moved around, which is a bit of a risk at this current time. There's also limited ability for version tracking, updates, and timestamps, including the signature of the subject matter expert and the timestamp of their signature on the report. And at this moment in time, there's limited database capabilities for structural variants. There are some updates needed for the ISCN nomenclature. And at this moment in time, it doesn't communicate with the LIMS system. So that brings me to the end. In summary, we have had some good success with streamlining our workflows. We will be able to free up some space in the lab, and we will be able to train more technologists on the technology than we were able to before. So thank you very much.